This video is for chapter 2, and this will be teaching you about temperature scales. Now, the first thing we need to do is to define a temperature. What is it? And a lot of students think, on a practical way of thinking of temperature is just that it's how hot or cold something is. But to really look at what temperature measures, it's measuring how fast the molecules inside the object are moving. So we say that by saying it's the measure of the average kinetic energy. Kinetic energy means motion. So average motion of the particles in an object. The faster the particles are moving, the higher its temperature. The slower the slower the particles are moving, the lower the temperature. Now, we are most accustomed in our everyday life to hearing degrees Fahrenheit. That's what our weather is reported on, and when we take to see if we have a fever, we're trying to see if we have it over 98.6 degrees Fahrenheit. Now, in science class, we don't use degrees Fahrenheit hardly ever. We use Celsius more commonly. And sometimes we will also need to use a Kelvin scale, which I'll explain to you here in a moment. So it's best to understand the three by comparing them. And we're going to look at a substance that we are familiar with. We're going to look at water. We should know the boiling and the freezing points of water and be able to compare them across all three temperature scales. So the blue one we'll call that degrees Fahrenheit. So at the top of that on your note sheet, make sure you label that correctly. For the red one, we'll call that degrees Celsius, okay? And for the green one, that will be our Kelvin scale. Now you might notice that when I made the Kelvin symbol, I did not need the little degree symbol. That's the way it's done. So boiling water. In Fahrenheit, water boils at 212 degrees Fahrenheit. And it freezes at 32 degrees Celsius. Now, in Celsius, when they decided to make this temperature scale Celsius, they wanted more useful, easy to remember numbers. So they picked the boiling point of water, they arbitrarily picked it to be 100. And they said that we would arbitrarily pick the freezing point of water to be 0. Those are nice, easy numbers for people to remember. So if you notice, if you were to take the difference between the 212 and the 32, you'd have 180 degrees between freezing and boiling. But on the Celsius side, the difference is obviously only 100 degrees. And what that's trying to tell you is that a degree Celsius is actually a bigger degree than a degree Fahrenheit. They are not the same. Now, the Kelvin scale was developed to define something called absolute zero. If you go back to remembering that temperature is a measure of a motion of molecules. Faster moving molecules have higher temperatures. Slower moving molecules have lower temperatures. We defined then absolute zero to be the place where all motion of those molecules stop. So Kelvin's lowest possible temperature is a 0 mark. There are no negative values in the Kelvin scale. So no negative values at all for Kelvin. And that'll be helpful when we study gas laws much later in the year. Now, they wanted the degree Celsius and the degree Kelvin to match. And so what they decided was that they defined this Kelvin freezing point of water, or 0 degrees Celsius, is the same as 273.15, technically, degrees Kelvin. Now, we usually just use 273. But the step between a degree Celsius and a degree Kelvin would be the same. So 100 degrees later at 373.15 would be the boiling point of water in Kelvin. So if you do your math and you think about it, that means absolute zero in Celsius should be negative 273.15. Again, we usually just use the whole number, negative 273. And then absolute zero in Fahrenheit, if you do the conversion, you'd get about 459 below zero. That's roughly an estimate. In our class, since we're focused mostly on Celsius at all times, and occasionally we will need to use Kelvin, we're going to teach you how to convert from Celsius to Kelvin or from Kelvin to Celsius. You can easily look up a conversion for Fahrenheit to Celsius if you need it, but we probably won't use it regularly in class. So if I have a degree Celsius and what I want to do is get it to Kelvin, hopefully you figured out that you just need to add 273. Now, technically, it could be 0.15, 273.15, but we're not going to be that worried about it. So we'll say simply that to convert from degrees Celsius to Kelvin, all you do is add 273. If what you want to do is take the Kelvin temperature and turn it back to Celsius, all you have to do is subtract 273. So the Kelvin temperature minus the degrees Celsius, or minus 273, excuse me, would give us degrees Celsius. So you could do this very simply. If I ask you 25 degrees Celsius, and I ask you to convert that to Kelvin temperatures, you should be able to do that. And if I have a Kelvin temperature of something like 262 Kelvin, I could ask you how to convert that into Celsius. And those will be your learning checks. So go ahead and do those, and good luck. Thanks.